February 20th, 1943. North of the barren ridgelines near the Kasserine Pass in Tunisia, a handful of German tank commanders found themselves witnessing something they could not immediately explain, something that contradicted every assumption, every piece of doctrine, and every scrap of battlefield logic they had been taught in years of service under the black-crossed banners of the Panzerwaffe, because what advanced toward them through the morning dust was not simply a platoon of American tanks, but an armored formation moving with a unity so precise and so fluid that it seemed almost supernatural, as if each vehicle sensed the intentions of the others without signals, without flags, without runners, without the visual cues that German armored warfare relied upon since the first campaigns in Poland and France. And as the Sherman turrets dipped, swiveled, and advanced with perfect timing, the Germans realized they were facing a form of coordination they did not possess and could not yet comprehend. The after-action reports would later describe the engagement in technical language: Sherman tanks advancing from multiple vectors, using broken terrain, maintaining formation under limited visibility. But these clinical descriptions could not capture the unsettling truth felt by the crews of the Panzer forts that morning. Men who strained to hear their company commanders over a wall of static pouring through their Fug 5 receivers. Men who adjusted dials with trembling hands as engine noise and electrical interference drowned out critical orders. Men who knew that only the platoon leader and perhaps one other tank possessed full transmitters, while the remaining vehicles could only listen, never speak, never warn, never report what they saw, leaving each tank dangerously isolated in the chaos of battle. At that time, the German army still believed it held the intellectual high ground in armored communication, confident in decades of radio doctrine dating back to Heinz Guderian's earliest writings. Yet as 5 American Shermans, separated by gullies and rock shelves that prevented any visual contact, swung inward with the timing of a single organism, the Germans realized that what they faced was not a maneuver generated by discipline alone, but by an invisible technological advantage, one transmitted not through the air by shouted orders, but through electromagnetic waves carried with such clarity that American crews could coordinate faster than the Germans could react. The truth, of course, was buried inside each Sherman's fighting compartment: 181 pounds of American engineering, designated SCR 508. A frequency-modulated radio set that German intelligence had not yet identified, a device whose 25-watt crystal-controlled transmitter cut through dust, vibration, and engine roar with a sharpness no German amplitude-modulated system could match. A radio so advanced that it allowed every American tank, not just command vehicles, to speak across miles of terrain, to warn, to adjust, to flank, to converge, to fight as a single network rather than as isolated machines. The battle that morning unfolded under the same harsh North African sun that had punished both armies for months, but buried beneath the surface of that clash was a revolution whose significance eluded the German commanders watching through their periscopes. Because they saw only tanks, Shermans and Panzer IVs trading fire across an unforgiving landscape, while failing to see the invisible architecture connecting those American machines into a unified fighting organism, an architecture that would change armored warfare forever and redefine victory not through armor or firepower, but through information. As artillery boomed in the distance, and American tank commanders spoke calmly into throat microphones, receiving and relaying orders on channels that never drifted, never drowned in static, never vanished behind a ridge or curve of terrain, the Germans found themselves fighting an enemy that seemed to anticipate movements before they happened, an enemy whose battlefield awareness extended beyond the horizon, an enemy whose coordination they attributed, wrongly, to discipline, training, or luck. In reality, the explanation lay thousands of miles away in Detroit and Chicago, where American engineers had spent years solving problems that German designers had not even begun to confront, creating not simply radios but the world's first battlefield communication network, a system so robust that even scattered, inexperienced American armored units could maintain cohesion across miles of broken ground, while veteran German companies, armed with superior optics and thicker armor, struggled to pass a single coherent order between tanks separated by mere hundreds of meters. And it was in that moment, dust rising, Sherman silhouettes, tightening their attack pattern, German radio static smothering critical commands, that the first cracks appeared in the Wehrmacht's armored doctrine, cracks created not by American guns, but by American signals, because the story of the Sherman tank is often told through the lens of its weaknesses, its armor, its gun, its vulnerability. But its greatest strength was invisible, carried on radio waves, transforming it from an average medium tank into a node in the world's first armored battlefield network. The transformation had begun long before the first Sherman ever rolled into Tunisia, beginning officially on July 22, 1941, when the U.S. Army standardized 3 remarkable Signal Corps radio sets, SCR-My 508, SCR 528, and SCR 538, for all medium tanks, a decision made while German armored divisions surged eastward into the Soviet Union, relying on radio architectures conceived in the 1930s, systems that had been revolutionary in the era of Poland and France, but were now aging rapidly under the strain of modern mechanized warfare. Behind the walls of the Galvin Manufacturing Company, soon to be known worldwide as Motorola, a small team of engineers led by Daniel Abreu, noble and principal RF engineer Henry Magnuski, began solving the challenges that German designers had dismissed as impractical, perfecting the use of frequency modulation in armored vehicles, creating a system capable of filtering out engine noise, vibration, and electrical interference. The very problems that crippled German amplitude-modulated radios under battlefield conditions. Their transmitter, designated BC-604, was astonishingly powerful for its size, generating 25 watts of output, 2.5 times stronger than the German FOG, while maintaining crystal-controlled stability across 10 preset channels, a degree of precision German tank crews could scarcely imagine, as they tuned dial-type receivers that drifted whenever temperatures shifted or vibration increased, causing messages to fade, distort, or vanish entirely at the moment they were needed most. Inside an American Sherman, however, the story was different. The BC-603 dual receivers allowed tank commanders to monitor 2 channels at once, keeping contact with platoon and company nets simultaneously, enabling coordination that would prove decisive in every campaign from North Africa to Germany, while the intercom system, comfortable throat microphones, noise-canceling headphones, filtered power supplies allowed every crew member to communicate effortlessly amid the deafening roar of combat. By contrast, many German tanks lacked intercoms entirely, forcing communication by touch, shouting, or tapping helmets, methods that were archaic, even by early war standards, and catastrophic when facing opponents whose information flowed without interruption through every vehicle in the formation. And as America prepared for Operation Torch in late 1942, shipping its first armored units toward the shores of North Africa, it unknowingly carried with it the most advanced battlefield communication technology of the war, a technology the Germans had not anticipated, had not intercepted, and had not prepared to counter, ensuring that when the Sherman tank finally met the Panzer IV, the battle would be decided not by steel but by sound, clear, stable, uninterrupted sound carried across miles of desert. When Operation Torch began on November 8, 1942, bringing American armor ashore at Safi, Fedala, and Oran, the German High Command still believed that its own Panzerwaffe possessed the most experienced tank crews and the most reliable command structure in the world. Yet as the first American armored spearheads pushed inland, something immediately disrupted the assumptions held inside Afrika Korps headquarters, because although American units were inexperienced, scattered, and often tactically clumsy, they displayed one capability the Germans had never seen before in any opponent: the ability for every single tank, whether leading, flanking, or trailing miles behind, to communicate instantly, clearly, and continuously with every other vehicle in its formation, a level of cohesion that shocked even hardened veterans of Rommel's campaigns. German intelligence officers monitoring American transmissions were the first to notice it. Their listening posts recorded radio traffic that seemed impossibly rich, dense, and well-structured, messages arriving without the static, distortion and frequency drift that plagued German sets, creating an eerie impression that American tanks possessed a kind of omnipresence, reacting to threats reported from kilometers away with a speed and precision that German operators simply could not match, no matter how aggressively they tuned their Fog 5 dials in a desperate attempt to cut through the interference. The structural weakness of German armored communication became visible almost immediately, for while American crews coordinated effortlessly across the battlefield, German tank platoons remained bound by rigid hierarchy, dependent on a single fully equipped command tank whose destruction instantly plunged the entire unit into chaos, as the remaining vehicles, carrying only receivers, could hear orders but were incapable of sending information back, effectively transforming them into mute participants on a battlefield where the Americans spoke constantly and freely, weaving a fabric of communication so dense that even green crews could maintain cohesion in situations that would have shattered more experienced units. This gap became brutally apparent during the fighting at Kasserine Pass in February 1943, where German maneuver skill temporarily overwhelmed American defenses but failed to conceal a more profound truth. Even in defeat, American tanks were demonstrating a form of battlefield coordination that German officers found deeply unsettling, because scattered U.S. armored groups, separated by miles of rugged terrain and often made up of crews who had never met, were still able to converge, warn each other, and call artillery with a level of clarity that seemed impossible under the din of engines and explosions. It was during one of these chaotic engagements that German signals analysts filed a report, noting with uncharacteristic alarm that American transmissions were exceptionally clear, free of static and coherent over unusually long distances, a statement that would later be recognized as one of the earliest German acknowledgements of FM's superiority over AM, though at the time it was dismissed as an oddity, a temporary anomaly, a quirk of atmospheric conditions rather than the revelation it truly represented. The Germans did not yet realize that every American tank, no matter how far down the chain of command, possessed a transmitter as capable as that of the platoon leader, allowing any crew to assume command in an instant if needed, a flexibility so alien to German doctrine that even when officers witnessed it firsthand, they interpreted it as improvisation or reckless initiative, rather than the product of standardized, networked communication woven into every Sherman shipped from Detroit. But nature revealed the gap even more brutally than combat did. When American tanks reached the Atlas foothills and climbed into the broken mountain passes of Tunisia, the Germans fully expected their own radios to outperform those of the enemy, assuming that the challenges of multipath interference, signals bouncing unpredictably off cliff faces and ridgelines, would cripple American systems, yet the opposite occurred. FM radio thrived where AM died, its resistance to distortion, allowing American tank commanders to navigate terrain that silenced German sets entirely, giving the Americans a decisive advantage in landscapes that German doctrine insisted required visual contact to maintain formation integrity. It was here, among cold ridgelines and narrow passes, that German tank commanders first spoke privately of their opponent's ghost coordination, the uncanny ability of Sherman units to correct course, flank ambushes, and mass firepower at exactly the right moment, even when separated by barriers that should have made communication impossible. They did not yet understand that this phenomenon was not supernatural at all. It was the inevitable consequence of a simple but devastating disparity. While German radios were designed for an earlier era of warfare, American engineers had built the first armored communication network strong enough to function regardless of environment, whether in desert heat, mountain shadows, or the dense hedgerows that lay ahead in France. And in North Africa, the Germans were experiencing this revolution early and painfully, watching formations of Sherman's maneuver as though they shared a single mind while their own tanks fought in near isolation, bound by the limits of outdated technology. When the Allied invasion of Italy began in September 1943 and American armored units pushed into the mountainous spine of the peninsula, German commanders believed, at least initially, that the rugged terrain would neutralize whatever advantage the Americans possessed, because in theory, No radio, regardless of quality, could reliably function across the defiles, ridgelines, and deep valleys that carved the Italian landscape into a maze of dead zones. Yet what unfolded over the following months did not simply challenge that belief, it shattered it entirely, revealing a technological gulf so wide that even the most experienced panzer officers found themselves unable to explain how American armored units were maintaining coordination in terrain where German radios produced only silence. In the passes leading toward Monte Cassino, American tank platoons, separated by entire hillsides, continued to maneuver with uncanny precision, synchronizing their movements with infantry units, artillery batteries, and adjacent armored elements, creating an operational rhythm that defied the jagged topography. While German tank commanders, crouched inside their Panzer Thors and Panthers, turned their receiver dials again and again as their Fug-5 sets dissolved into waves of static that rendered even short-distance communication unreliable. To the Germans, it seemed impossible that tanks they could not see, and sometimes could not even hear, were nonetheless responding instantly to developments occurring on the far side of a ridge, adjusting speed, repositioning turrets, and coordinating fire as if the mountains themselves were transparent, as if no obstacle existed between one Sherman and another. And it was here in the deep gullies and narrow passes of the Italian front that FM technology revealed its full strategic dominance over AM. Shrugging off the multipath interference that crippled German radios and delivering to American crews the clarity they needed to outperform opponents who often fought blind. After-action reports from the U.S. 1st Armored Division routinely described tank platoons maintaining effective communication across distances and terrain features that German doctrine insisted were insurmountable barriers, and yet these same reports often appear understated compared to the testimonies of German officers who faced them, men who admitted privately that American tanks seemed to coordinate as though linked by wires, a phrase repeated in several captured notebooks, revealing bewilderment at a technology they could hear but not understand. German signals intelligence units stationed in Italy intercepted hundreds of American transmissions throughout the winter of 1943-44, and their reports grew increasingly anxious, noting that American forces maintained stable contact during situations in which Fugate-5 sets failed completely, whether due to humidity, interference, engine vibration, or simple distance. The German operators, trained to interpret static as atmospheric noise, heard instead the clear, undistorted voices of American tank commanders speaking calmly, relaying coordinates, calling artillery, adjusting formation, and describing enemy movement with a precision that German armored units could not hope to match under the same conditions. The Germans initially attributed this American clarity to discipline, assuming that American tank crews simply spoke less, used simpler phrases, or followed stricter radio procedure. But as the campaign progressed, it became undeniable that a technological gap, rather than a doctrinal one, was determining the outcome of countless engagements, allowing American forces to synchronize combined arms operations with a speed and reliability that German units could not replicate, even with veteran crews and superior individual tank designs. It was during the Cassino battles, fought amid shattered stone, crumbled monasteries and tangled farm roads, that the contrast became almost grotesque. American tanks, each armed with SCR 508 radios, could instantly relay threats spotted by infantry, coordinate movements across adjacent valleys, and call fire missions within minutes, while German tanks, many of them equipped only with receivers, could hear orders but could not report enemy flanking maneuvers, could not warn adjacent units about roadblocks or ambushes, and could not request artillery support when pinned down, forcing platoons to either fight independently or rely on slow, vulnerable runners to carry critical messages. This isolation eroded German tactical cohesion, with each passing week, creating a battlefield environment in which American armored units, despite their thinner armor and less powerful guns, consistently outmaneuvered German formations that should, by all conventional logic, have held the advantage in direct combat. The greatest irony was that Heinz Guderian, the very architect of Blitzkrieg, had warned as early as the 1920s that tank warfare lived or died through communication, insisting that radios were the nervous system of the armored force. Yet by 1943, German industry could not produce enough modern transceivers to equip its own formations, while American factories, fueled by relentless industrial capacity, were issuing tens of thousands of advanced FM radio sets each year, ensuring that every single Sherman tank, regardless of role or assignment, entered battle fully integrated into a larger network. Thus, in the mountains of Italy, under rain, fog, and artillery smoke that should have neutralized electronic communication, the Americans discovered that their frequency-modulated radios did far more than outperform German sets. They changed what armored warfare was, turning individual tanks into participants in a dynamic, interconnected organism that extended across valleys, ridges, and rivers, while German formations, fighting with heroic discipline but crippled by technological limitations, found themselves increasingly outmaneuvered, outflanked, and outpaced by opponents who seemed to be everywhere at once. When American Sherman tanks rolled off the landing craft onto the beaches of Normandy on June 6, 1944, struggling through seawater, machine gun fire, and shifting banks of sand, they carried inside them not only the crews who would fight across France, but the full maturity of the radio revolution that had begun 3 years earlier. A revolution the Germans still had not recognized, even as their own tank commanders continued to battle the same old limitations of AM interference, channel drift, and equipment scarcity that had plagued them in Africa and Italy. And it was in the hedgerow labyrinth of Normandy that this unseen American advantage became not just tactical but existential. The Norman bocage, dense, ancient earthworks crowned with thick hedges and broken only by narrow lanes, created one of the most challenging environments for armored warfare ever encountered by Western armies, a place where visibility collapsed to mere meters, where enemy infantry could hide in any shadow, and where tanks advancing blindly through earthen corridors risked ambush at every intersection. Yet it was here, in terrain tailor-made for defensive warfare, that the fundamental divide between American and German communication systems carved the battlefield into two very different realities. For American crews, the SCR 508 radios allowed Sherman platoons to whisper through the hedges, coordinating each hesitant advance with the calm precision of men who knew they were never alone, who knew that even when stopped by an unseen obstacle, they could immediately call to tanks hundreds of meters away, adjust angles of advance, request artillery, or warn infantry about enemy positions hidden just beyond the next hedge, creating a fluid environment of shared information that dampened fear, reduced confusion, and turned the claustrophobic bocage into a navigable, though perilous, combat zone. For German Panzer units, however, the same hedgerow terrain amplified every weakness of the 5.5 radio system, which, already prone to interference and short range, became almost unusable in the tight earthen corridors of Normandy. Static overwhelmed transmissions, ranges shrank to mere fractions of a kilometer, and tank platoons found themselves fighting in disconnected pockets, each vehicle essentially isolated from its neighbors, forced to rely on guesses or pre-arranged signals rather than real-time communication, a disadvantage that grew more lethal with every passing day of combat. The inability of German infantry and armor to coordinate effectively in the bocage became painfully clear to American tankers who, despite suffering heavy losses from Panzerfaust ambushes, began to understand that their opponents often could not react cohesively. Once the first shot was fired, a German tank or assault gun caught off guard might fire back powerfully, might even destroy multiple Shermans, but its ability to warn supporting units or request reinforcement was crippled by the limitations of its AM radio equipment, allowing American units to isolate and overwhelm German armored forces piece by piece. A critical weakness soon emerged in the American system as well: the incompatibility between tank radios and infantry radios, a flaw that resulted from tanks operating in the 20.0, 27.9 MHz range, while infantry radios like the SCR 300 operated between 40.0 and 48.0 MHz, meaning that in the tangled hedgerows American infantry, often could not warn tanks about German soldiers lurking just meters away, with Panzerfausts, leading to devastating close-range ambushes that threatened to stall the entire Normandy campaign unless a solution could be devised. And in the typically pragmatic American way, the solution arrived not as a sophisticated electronics upgrade, but as a crude, improvised field innovation. Tank crews began welding ammunition boxes to the rear hull of their Shermans, mounting EE-8 field telephones inside them, and wiring them directly into the tank's intercom systems, creating an external handset that infantry could use to speak instantly with tank commanders. This invention, simple, rugged, and immediately effective, transformed combined arms operations in the Bocage, giving infantry the ability to warn tanks instantly of ambushes, coordinate movement through hedges, and direct close support fire, with a level of precision that German doctrine could not match. By the time Operation Cobra began on July 25, 1944, unleashing the massive American breakout west of Saint-Lô, this melding of tank and infantry communication had matured into a seamless system, allowing the U.S. 2nd Armored Division under Major General Edward H. Brooks to coordinate more than 200 Sherman tanks with an efficiency that left German observers stunned, because within minutes of receiving reconnaissance reports, American tank columns could shift direction, redistribute firepower, and execute large-scale maneuvers that German units, hampered by poor communications and battered by Allied air power, simply could not respond to in time. The Panzer Division, once the pride of Germany's armored corps, found itself facing an enemy that seemed omnipresent, reshaping the battlefield faster than German commanders could issue orders. And as Shermans advanced under a rolling thunder of artillery coordinated through their SCR 508 radios, Panzer Lehr's tanks and half-tracks were forced to rely on visual signals in terrain where visibility rarely exceeded 100 meters, reducing their tactical behavior to instinct and proximity rather than coordinated doctrine, a deadly disadvantage in the era of fast-moving mechanized warfare. Thus, in Normandy, amid the hedges that swallowed entire regiments, the Americans proved the central truth of modern armored combat. The tank with the best gun may win the duel, but the tank with the best communication wins the battle, because it fights not as a single machine, but as part of a synchronized organism whose strength is magnified by every vehicle connected through the invisible architecture of radio. By late July 1944, as the dust from the Saint-Lô bombardment settled and the American breakout operation Cobra began to unfold, the U.S. Army was about to demonstrate something far more profound than armored superiority. It was about to showcase the first large-scale application of what modern strategists would later call network-centric warfare, a mode of combat in which speed, awareness, and coordinated response mattered more than armor thickness or gun caliber. And the very heart of this transformation pulsed inside every Sherman tank, humming softly through the SCR 508 radios that linked hundreds of vehicles into a single, responsive battlefield organism. Major General Edward H. Brooks, commanding the 2nd Armored Division, was one of the first American commanders to fully exploit the potential of tank radios in an operational context, using the SCR 508 network to coordinate more than 200 Sherman tanks, tank destroyers, armored infantry units, and artillery observers with a fluidity that German commanders simply could not emulate, because while the Germans were still attempting to pass orders through constricted chains of command or via visual signaling, Brooks' units were adapting their formations minute by minute, sweeping around strong points, shifting axes of advance, and synchronizing fire missions across miles of countryside as though the entire division shared a single nervous system. To German forces, especially those of the Panzer Lehr Division, this appeared almost supernatural. They watched American tank companies maneuver in patterns that defied the logic of German doctrine, reacting immediately to threats reported far beyond visual range, redirecting firepower across multiple sectors, and massing tanks at precisely the right moment, without the long delays that usually accompanied armored movements in conventional doctrine. Delays caused by runners, dispatch motorcycles, or fragile wired communications that could be severed with a single artillery shell. But behind this apparent American intuition was a radio architecture that remained invisible to German observers, who continued to judge the Sherman tank primarily by its gun and armor, while failing to recognize that, for the Americans, the tank's true weapon was the ability to communicate swiftly, clearly, and universally across an entire division, eliminating the fog of war, while German formations still struggled with radios that worked only intermittently and reached only a fraction of the units that needed them. German intelligence assessments from this period read almost tragically in hindsight. A captured September 1944 report, for example, attempted to analyze the surprising cohesion of American tank forces during Cobra, and concluded that American armored units demonstrate strict communication discipline and a high level of training, a statement that completely misinterpreted the situation, because what German officers perceived as discipline was actually infrastructure, an FM-powered information network in which every tank could transmit, receive, relay, and coordinate without the static, drift, or signal collapse that tormented their own fifth 5 sets. As the breakout accelerated, the Americans began linking artillery directly to their armored spearheads through the SCR 508 system, meaning that a Sherman tank commander who spotted a German position could call for a fire mission that would arrive within minutes, sometimes before German units even understood they had been detected, while German armored formations, lacking reliable radios, often had to rely on pre-arranged bombardments or slow, fragmented communication chains that rendered them tactically rigid and operationally vulnerable. This flexibility reached its peak during the dramatic encirclement battles that followed Cobra, where American tanks outran German assumptions, collapsing defensive lines not through overwhelming firepower, but through overwhelming information, acting as scouts, shock troops, and mobile command posts all at once, while German armored units, no matter how capable their individual machines, were forced to fight as isolated pockets, deprived of awareness, unable to coordinate withdrawals, counterattacks, or even basic defensive realignments. The contrast became stark in the fighting against the newly formed Panzer brigades in late summer 1944, units equipped with superior Panther tanks that should have posed a dire threat to the advancing Americans. Yet these brigades assembled hastily and issued radios in insufficient quantity, often attacked in silence, unable to adjust to the ever-shifting American deployment, and German commanders repeatedly lamented that their formations broke apart upon first contact, not because the crews lacked courage, but because their communications disintegrated. The moment the lead tanks were knocked out, severing the fragile chain of command and leaving the remaining vehicles blind, mute, and alone. It was here that American armored doctrine, rooted in universal radio deployment, demonstrated its most decisive effect. Even when lead Shermans were destroyed, even when formations became scattered across fields, crossroads, or villages, every surviving tank could instantly re-establish contact, reorganize on the fly, assume command roles, and continue the attack without hesitation, creating an unbroken operational momentum that German armored units, fragmented by communication failure, simply could not match. Thus Cobra was not just a breakthrough, it was a revelation, proving that in mechanized warfare, the true advantage belonged not to the tank with the thickest armor, nor the gun with the highest muzzle velocity, but to the force that could gather, share, and act upon information faster than the enemy could comprehend it. The Americans were no longer simply advancing, they were demonstrating the future. By September 1944, as the U.S. Third Army surged eastward across France under the relentless momentum generated by Operation Cobra, the German High Command attempted one final, desperate measure to halt the American advance: the deployment of newly assembled Panzer brigades and veteran units equipped with Panther tanks, machines whose thick sloped armor and high-velocity 75 mm guns were on paper far superior to the Sherman's lighter armament and thinner hull. Yet what unfolded in the fields around Aricourt did far more than demonstrate American tactical competence. It revealed that even the finest German tanks, when stripped of effective communication and forced to operate in near silence, could not overcome an enemy whose greatest strength was not armor or firepower, but information. The Battle of Aricourt, fought between September 18th and October 2nd, 1944, became the crucible in which German assumptions about armored superiority were shattered, because here, under fog-choked mornings and low-hanging autumn clouds, the U.S. 4th Armored Division used its radio-powered cohesion to dismantle a series of German armored thrusts that should, by all conventional calculations, have overwhelmed them. Yet each time German Panthers attempted to mass for a coordinated attack, their formations fractured almost immediately, not due to American fire, but due to their own inability to communicate reliably across even modest distances. The newly formed Panzer brigades, rushed into battle with minimal training and insufficient radios, found themselves fighting in a state of permanent confusion. Platoon leaders attempted to issue orders through Fu-5 transmitters that barely carried through the morning fog, while subordinate tanks, equipped only with receivers, could not report enemy contact, could not request support, and could not warn adjacent units when ambushed by concealed American armor that responded quickly and coherently to every shift of the battle. American tank destroyer battalions, especially those equipped with M18 Hellcats, exploited this paralysis to devastating effect. Using the clarity of their FM radios, they coordinated hit-and-run attacks, repositioned rapidly, and relayed German movements in real time to artillery observers, traveling inside Sherman command tanks, who in turn directed fire missions that arrived with astonishing speed, often within minutes, obliterating German assault groups before they could regroup. A feat made possible only because American communication networks allowed every armored element to see, in effect, through the eyes of every other. German accounts of Aricourt repeatedly describe moments in which Panther crews, operating without situational awareness, drove directly into American ambushes, unaware that the units they believed were supporting them had already been destroyed or had retreated, with one German officer later writing that our tanks moved forward as individuals, not as a unit, a phrase that perfectly captured the fragmentation inflicted by communication failure. A fragmentation no amount of armor could compensate for. American crews, meanwhile, fought with a confidence born from constant connectivity. Even when separated by fog, terrain, or dust, they knew that a single radio call would be relayed instantly across their network, updating nearby tanks, cueing artillery, or directing tank destroyers to exploit openings, creating a fluidity of movement that made their formations feel larger, faster, and more responsive than their numbers suggested. A psychological advantage as real as any technological one. In one of the most telling examples, a group of American light tanks vehicles utterly outmatched in a direct engagement survived a German armored thrust simply because their rapid, radio-enabled warnings summoned reinforcements and directed them into flanking positions before the German Panthers realized they were exposed, a maneuver that would have been impossible for German crews, who lacked the means to share such real-time information across even short distances. By the battle's end, the scoreline spoke for itself. The U.S. 4th Armored Division had destroyed more than 280 German armored vehicles, while losing only 41 Shermans, a kill ratio of nearly 7-to-1, an outcome that defied expectations and proved beyond dispute that in modern mechanized warfare, tank with superior communications will consistently defeat the tank with superior armor, because armor protects a machine, but communication empowers an army. German intelligence officers reviewing the disaster still failed to identify the true cause, attributing American success to good tactical handling or careful training, missing the fundamental truth that American tank formations were fighting not as individuals but as interconnected nodes in a unified combat network, while German units, crippled by limited radio distribution and outdated AM technology, were forced to fight blind, deaf, and alone. Thus Aricourt became more than a battlefield victory. It became proof of a principle that would define all future armored warfare: the ability to communicate, to know, to decide, to act, matters more than the thickness of steel or the caliber of a gun, because the army that shares information the fastest will always, By early 1945, as Allied armies approached the frontiers of the Third Reich and the once formidable Wehrmacht struggled to maintain any semblance of coordinated defense, the contrast between American and German communication systems reached a dramatic and final climax. Because the closer the fighting moved toward Germany's industrial heartland, the more the war became a race of coordination, speed, and response time, factors in which the SCR 508 network transformed American armored units into an unstoppable force, while German formations, bound to fragile AM radios and fragmented command structures, collapsed under the weight of their own isolation. This disparity became painfully visible in March 1945, during one of the most strategically significant events of the entire European campaign, the capture of the Ludendorff Bridge at Remagen. When scouts of the U.S. 9th Armored Division unexpectedly found the bridge still standing, against all German expectations, they transmitted the news across their FM network within seconds, triggering a cascade of radio traffic that leapt from battalion to regiment to corps with astonishing speed, allowing American commanders to redirect entire divisions toward the Rhine in less time than it took German headquarters even to understand what had happened. While American radios crackled with crisp, coordinated orders instructing armored columns to accelerate toward Remagen, German units relied on telephone networks that had been systematically destroyed by Allied air power, forcing staff officers to send messages by motorcycle courier or fragmented radio nets that dissolved into static. The moment vehicles moved or terrain intervened, the result was chaos. German reinforcements arrived piecemeal, unsupported, and often unaware of the positions of adjacent units, creating conditions in which American tanks, already across the river, were able to establish a defensive perimeter faster than German counterattacks could be organized. The FM network that linked American tank platoons also linked them to forward air controllers riding in armored vehicles, enabling them to summon P-47 Thunderbolts and P-51 Mustangs with devastating accuracy, guiding airstrikes in real time against German artillery positions, troop concentrations, and vehicle columns as they stumbled toward the bridgehead without coherent direction. To German observers, it appeared as though American air power responded instantly to battlefield developments, yet behind every attack was a Sherman commander speaking through an SCR 508 set, relaying coordinates with clarity that German operators, still fighting their own radios for intelligibility, could scarcely believe possible. This pattern repeated itself across the Ruhr in April 1945, when American forces executed one of the most complex double envelopments of the war, encircling 325,000 German troops in the Ruhr pocket. The success of this massive maneuver depended on the ability of separate armored columns advancing from different directions across varied terrain and at different speeds to maintain continuous contact, adjust their axes of advance, and seal escape routes before German units could reorganize. It was a feat made possible only because every Sherman, every tank destroyer, every command vehicle was bound into a cohesive communication grid that allowed the U.S. 1st and 9th Armies to behave like a single organism, tightening the noose with methodical precision. Inside the shrinking pocket, German units experienced the opposite reality, with telephone lines destroyed and radios crippled by range limitations. Many formations lost contact with higher headquarters entirely, fighting isolated skirmishes without understanding the broader situation, unable to coordinate withdrawals, supply lines, or counterattacks, while American armored thrusts, guided by seamless FM communication, methodically cut through remaining pockets of resistance. Field Marshal Walter Model's final messages, transmitted before his communication network collapsed entirely, described a situation in which units no longer knew the positions of adjacent formations and counterattacks failed due to lack of coordination. Statements that reflected not only battlefield pressure, but the catastrophic communication failures that rendered German forces strategically immobile despite their bravery and remaining firepower. By the war's final weeks, it had become undeniably clear, even to those within the German High Command, who had dismissed earlier warnings that the Americans' universal deployment of advanced tank radios had reshaped the strategic tempo of the conflict, enabling them to exploit opportunities with breathtaking speed, while German units drowned in delays, misunderstandings, and silence. Some German officers, reflecting bitterly after the war, admitted that American tanks seemed to act with one mind, while theirs acted only with their armor, a distinction that captured the essence of the technological revolution unfolding around them. Thus, by the spring of 1945, the war in Europe had become a living demonstration of the principle that information, its speed, clarity, and distribution, determines victory more decisively than any single weapon system. And while German engineers had built extraordinary machines of steel, they had neglected the invisible architecture of coordination, leaving their tanks powerful as individuals, but powerless as a collective force, while the Americans had built not just tanks but a network. By the time Germany capitulated in May 1945, the final and perhaps most tragic irony of the war had fully revealed itself. The nation that had pioneered the use of radios in armored warfare during the interwar years, the nation whose blitzkrieg doctrine depended fundamentally on fast, coordinated movement, had been outmatched not by superior tanks or overwhelming firepower, but by an opponent who understood more clearly how communication, not armor thickness, not gun caliber, was becoming the decisive variable of 20th century mechanized combat. American intelligence teams moving through ruined factories, abandoned vehicle depots, and shattered German headquarters found an arsenal of advanced engineering, Panther tanks, Tiger IIIs, innovative optics, rangefinders, and precision machined components. But they also found something else, something far more telling: a catastrophic shortage of modern radio equipment, a patchwork of outdated design principles, and a production philosophy that simply could not keep pace with a war in which information had become the most lethal weapon. Technical Intelligence Report, New May 176, compiled shortly after the German surrender, put the matter bluntly. German tank communications were approximately 5 years behind American technology, a gap that could not be overcome by battlefield improvisation or tactical expertise, because even the finest tank in the world is blind without reliable communication. A truth the Americans had recognized and codified long before their Shermans ever landed in Africa. The production numbers alone painted a devastating picture. In 1943, Germany produced nearly 5,700 medium tanks, Panzer IVs, Panthers, and others, yet manufactured fewer than 2,000 Forg 5 transceivers, meaning that at best, only 1 in every 3 tanks rolling off the assembly lines possessed a full transmitter-receiver set. The remainder were issued receivers only, or in many cases, nothing at all, creating armored formations where only a handful of vehicles possessed the ability to communicate upward or sideways in the chain of command. The Americans, by contrast, ensured that every single Sherman, all 49,324 of them, was equipped with advanced FM radio equipment, supported by an industrial system that produced more than 50,000 SCR 508 family sets. Enough not only to fill tanks, but to supply spares, training units, and replacements, guaranteeing that communication failure would never cripple an armored formation in the midst of battle. Soviet forces fared even worse than the Germans. Despite producing vast numbers of T-34 So, only a fraction entered combat with radio equipment, forcing Soviet crews to rely on flag signals, hand gestures, and rigid, pre-planned maneuvers that were devastatingly inadequate against a force that could adapt in real time to battlefield developments. Lend-Lease shipments of American radios helped, but even by the end of the war, only about 25% of Soviet tanks were equipped with effective communication systems, a limitation that constrained even their largest offensives. Thus, as American armored units raced across France, Belgium, the Netherlands, and into the industrial heart of Germany, the Germans fought desperately but increasingly blindly, unable to track the movements of American columns, unable to coordinate counterattacks across multiple sectors, unable to improvise when lead units failed, because the structural vulnerability that had haunted German armored forces since North Africa had grown fatal. They could not speak to each other, not reliably, not consistently, not at the scale required by modern mechanized warfare. Meanwhile, the Americans fought with the quiet confidence of a force that understood exactly where its units were, exactly what they faced, and exactly how to respond, even under the fog, noise, and terror of combat. Tank crews who were physically isolated, cut off by terrain, smoke, or scattered fighting, never felt operationally isolated, because one twist of the dial reconnected them instantly to the network, giving them access to reconnaissance, artillery, and the wider armored formation in a way German crews could only envy. Captured German officers repeatedly expressed astonishment at this American capability. One report from late 1944 noted that American armored units behave as though joined by invisible wires, a metaphor far closer to the truth than its author realized. American success was not an accident of leadership or luck, but the direct consequence of a technological ecosystem designed to eliminate the very chaos that had defined tank warfare since its inception. The philosophical divide became stark. German tanks fought as exceptional individuals, superb machines, brilliantly engineered, manned by skilled crews, but too often isolated, out of contact, and reactive. American tanks fought as a unified organism, adequate machines by themselves, but devastating when operating as nodes in a vast communication network. This distinction shaped the outcome of countless engagements, but it also shaped the post-war world. When the Bundeswehr was established in the 1950s, its generals, many of them former Panzer officers, ensured that every Leopard tank produced would carry advanced radios as standard equipment, explicitly citing the failures of WWW communication architecture as lessons learned in blood. A German training manual from that era even stated, "Superior armor does not compensate for inferior communication. Armored forces must fight as networks, not as individuals." American doctrine evolved along similar lines, ultimately leading to the development of fully integrated digital battle networks that defined US dominance in the 1991 Gulf War. And again, in 2003, where coalition forces equipped with modern communication systems outmaneuvered Iraqi units operating Soviet-era radio technology, proving once more that the decisive factor in modern combat is not the tank, but the network that binds the tanks together. And so, in retrospect, one of the most profound truths of mechanized warfare emerges not from the roar of engines or the crash of steel, but from something far quieter, the hum of radio signals pulsing across a battlefield, connecting machines, guiding men, dissolving uncertainty, and creating a form of collective intelligence that no isolated tank, no matter how thick its armor or powerful its gun, can ever match. By the time post-war analysts began studying the operational patterns of Allied and Axis forces, it had become increasingly clear that the most decisive American innovation of World War II was not the Sherman's gun, nor its armor, nor even its mechanical reliability, but rather the invisible architecture of communication that transformed each tank into a node of a synchronized organism, because what the SCR 508 system accomplished was nothing less than the creation of the world's first armored information network, a precursor to the digital battle systems that would define global conflict for the next century. Historians later referred to this phenomenon as the network beating the platform. The idea that the side capable of sharing information fastest will consistently defeat the side relying on the power of individual machines, and nowhere was this principle more vividly displayed than in the contrasting fates of American and German armored forces during the final year of the war. When American Shermans, operating under the connective fabric of FM radio, rapidly reorganized, concentrated fire, and delivered coordinated blows that far outweighed the power of any single tank, while German Panthers and Tigers, monsters of steel fighting often alone, cut off and uninformed, found themselves overwhelmed, not by superior vehicles, but by superior awareness. This was why engagements that should have favored German armor on paper, Aricourt, Montrevel, Dompierre, and the Lorraine battles, turned instead into catastrophic defeats, and as German officers were interrogated after the war, many of them expressed deep frustration at the communication paralysis they had experienced in the field, with one former Panzer battalion commander bitterly noting, "We had better tanks, but the Americans fought as a single machine. We fought as individual tanks." American commanders, by contrast, were often surprised by how completely German armored doctrine had failed to adapt to the new reality, because even as late as 1945, German officers were still organizing their tank battalions according to models developed during the early Blitzkrieg years. When radios were scarce, German forces were unopposed and the battlefield was relatively open, a structure that became disastrously outdated once they faced an opponent whose radios worked under every condition, moving, firing, climbing, crossing rivers, navigating forests, or fighting at night. The Americans had, perhaps unintentionally, discovered the primacy of communication stability, that a radio which functioned in the worst moments of battle was more decisive than an extra 20 millimeters of armor or a higher muzzle velocity, because a functioning radio multiplied the fighting power of every tank in the formation, allowing them to react as one, to strike in unison, to compensate instantly for losses, and to exploit opportunities faster than an enemy could react. Thus, even when German intelligence reports mentioned American remarkable coordination or unusual cohesion, they never grasped that these qualities were not the product of discipline alone, but of engineering, manufacturing, and doctrine that valued connectivity over individual vehicle performance, creating a system in which technological uniformity, every tank having the same radio, the same channels, the same intercom equipment, enabled tactical fluidity that the Germans, with their patchwork of AM sets, partial installations, and inconsistent distribution, could never achieve. In the decades that followed the war, military theorists and engineers slowly began to realize that the lessons of the Sherman's SCR 508 went far beyond the specifics of FM versus AM. What mattered most was the concept that a tank is not a weapon system by itself, but part of a larger network whose effectiveness depends on how well its elements can communicate. And this realization shaped the design of every Western armored platform that followed, from the M60 Patton to the M1 Abrams and Leopard 2, all of which were built around communication suites that would have been unthinkable without the pioneering work of Daniel Ear Noble, Henry Magnuski, and the Motorola engineers whose designs had given the Sherman its greatest strength. By the time the Cold War reached its climax, American and NATO doctrine had evolved into a fully network-centric philosophy in which tanks, artillery, aircraft, infantry, drones and satellites became linked through digital systems that traced their lineage directly back to the SCR 508, the first device to prove that battlefield awareness was a weapon more decisive than steel. A truth demonstrated again in the Gulf War of 1991, when American M1 Abrams tanks, equipped with advanced communication systems, annihilated Iraqi armored forces manning superior Soviet-designed T-72 so that lacked comparable connectivity, proving once more that the tank connected to the network will always defeat the tank cut off from it. This modern principle, connection equals survival, isolation equals defeat, was born not in the computer age, but in the dust of North Africa, the mud of Italy, the hedgerows of Normandy, and the foggy fields of Lorraine, where American tank crews discovered that the hum of an FM transmitter could mean the difference between life and death, victory and destruction, cohesion and collapse. And so when historians today look back at the M4 Sherman and ask how such a modest tank could play such an outsized role in defeating the armored might of Nazi Germany, the answer does not lie in the thickness of its armor or the sharpness of its gun, but in the invisible waves that passed between its crews, clear, stable, unbroken, waves that turned thousands of individual tanks into a single unified force, a force whose strength no German Panther or Tiger, fighting alone and unheard, could ever hope to match. As American forces closed in on the heart of Germany, in the final weeks of the war, and the last pockets of organized resistance collapsed under the pressure of coordinated armored thrusts, artillery barrages, and relentless air support, a profound realization began to crystallize among military analysts observing the battlefield. The M4 Sherman, so often criticized for its thin armor and average gun, had not won through brute strength or mechanical superiority, but through the quiet, unseen power of its communication system. A system that amplified the fighting capability of every crew, every platoon, every battalion, and ultimately the entire US Army. This truth was encapsulated by a remark, likely apocryphal, yet symbolically perfect, attributed to Field Marshal Wilhelm Keitel during the German surrender. "You built better radios. We built better tanks. You used yours to win." Whether he said those words or not, the sentiment captured the final, irrefutable lesson of the European campaign. A tank's worth is defined not only by its armor and firepower, but by its ability to be part of something larger, something interconnected, something aware of more than what the crew inside can see or hear. For the Germans, this lesson arrived too late. Buried beneath the rubble of cities and the remains of isolated panzer companies whose tanks had fought as individuals, brave but blind, powerful but uncoordinated, victims not only of American fire but of their own silence. Their factories had produced extraordinary machines, Panthers with fearsome guns and well-sloped armor, Tigers whose thick plates defied most Allied weapons, but they had failed to produce the connective tissue that allowed those machines to operate as a true system, leaving them vulnerable to enemies who understood that the future of warfare belonged not to the strongest machine, but to the most connected one. For the Americans, each Sherman tank was never truly alone, even when advancing into fog, smoke, or chaos. Each tank carried inside it the ability to speak across miles, coordinate flanking maneuvers, summon artillery, redirect infantry, or warn of dangers lurking beyond the next hill, all through the humming backbone of the SCR 508 radio system that transformed the battlefield into a living map, pulsing with information. This capability gave American commanders a degree of operational flexibility that German leaders could only envy, allowing them to reassign units, redirect advances, and exploit opportunities at a tempo that overwhelmed the increasingly fractured German lines. The distinction was stark. German tanks fought individual battles, bravely, often brilliantly, but in isolation. American tanks fought one single battle, a collective struggle in which information flowed freely, welding thousands of Shermans into a single organism whose awareness extended far beyond the line of sight of any individual crew. Modern military doctrine now recognizes this as the dawn of network-centric warfare, the foundational principle that shapes modern command systems, from digital battle networks to satellite-guided strike coordination. The M4 Sherman, humble in silhouette yet mighty in connection, became the prototype for all future armored doctrine. The idea that the real weapon is not the tank itself, but the network it belongs to. And so the true story of the Sherman tank, often overshadowed by debates over armor thickness or gun penetration, is ultimately the story of a revolution that happened not in steel but in the invisible spectrum of radio waves. A revolution that began the moment the first SCR 508 set was installed in a Detroit factory and continued through every battlefield from Tunisia to the Rhine. In the final analysis, American radio superiority did more than enable victory. It changed the very nature of warfare, proving that the decisive factor in mechanized combat is not merely how hard a tank can hit, but how well it can communicate, coordinate, and adapt. The Sherman tank, through its FM radio system, became not a solitary machine but a node in a vast synchronized network, one that saw more, reacted faster, and acted with a unity that no amount of German engineering could overcome. This was the invisible advantage that German troops never understood until it was far too late, and it remains one of the most important lessons of World War II. The side that can talk, clearly, instantly, continuously, will always defeat the side that cannot. In the decades that followed the Second World War, as military theorists, engineers, and commanders sifted through mountains of captured documents and testimonies, a new understanding began to take shape, an understanding that transcended the old debates about armor thickness, turret design, or the caliber of tank guns, because the deeper one looked into the campaigns of North Africa, Italy, France, and Germany, the more evident it became that the M4 Sherman's true legacy was not its mechanical construction, but the invisible lattice of communication that bound every tank, every crew, every platoon and battalion into a single integrated system, a system whose effectiveness rewrote the rules of mechanized warfare and redefined victory on a battlefield dominated as much by information as by steel. The SCR-508 radio, born in American laboratories and refined through brutal field testing, was more than a device. It was the nervous system of an entire army, a tool that allowed inexperienced tankers to fight with the awareness of veterans, that allowed scattered units to behave as one, and that allowed American commanders to shape the tempo of combat with a flexibility their opponents could scarcely comprehend. It turned chaos into coherence, fog into clarity, and the unpredictable violence of armored warfare into a coordinated ballet of movement, reaction and response. German forces, for all their engineering brilliance and tactical discipline, never grasped this transformation until the consequences had already sealed their fate. They continued to build magnificent tanks that fought as isolated titans, unaware that the Americans had built something far more powerful than any single machine. They had built a network, a living tactical organism that expanded with each new Sherman rolling off the production line. Each tank entering the battlefield as another node in a vast chain of communication that amplified strength and minimized vulnerability. This was why American breakthroughs seemed sudden, why counterattacks arrived with uncanny speed, why artillery fire fell with surgical precision, why German ambushes, devastating at first contact, collapsed under coordinated counterfire before they could exploit their initial advantage. The Americans were not simply faster, they were more connected, able to absorb battlefield information and redistribute it instantly to every element of the force, while German units suffered from fragmentation, delays and blind spots that no amount of bravery could overcome. In hindsight, modern militaries recognize the Sherman's communication suite as the beginning of a new epoch, the first step toward the digitized command systems, integrated data networks, and real-time battlefield awareness that define contemporary armored warfare. The lineage is unmistakable, from the SCR-508 in 1942 to the SINGAS systems of the late 20th century, to the hyper-connected battlefield architectures used today. The principle remains constant. The force that sees first, shares first, and reacts first holds the decisive advantage. Thus, the story of the Sherman tank is ultimately the story of a shift in the nature of warfare itself, a shift from platform superiority to information superiority, from isolated machines to interconnected networks, from individual duels to collective intelligence. It is the story of how electromagnetic waves, silent, invisible, and often overlooked, proved more lethal than thick armor or high-velocity guns, shaping battles, altering campaigns, and determining the fate of nations. And long after the last Sherman was retired, long after the fires of the Second World War faded into history, the lesson it embodied endures in every modern tank rolling across training grounds, in every armored division rehearsing maneuvers, in every digital system linking satellites, aircraft, infantry, drones, and armor into a cohesive whole. Connection is strength, coordination is power, and the army that fights as a unified organism will always overcome the army that fights as isolated individuals. German troops discovered this truth in Tunisia, in Italy, in Normandy, in Lorraine, and along the Rhine, discovering too late that the Americans had not merely fielded more tanks, or better logistics, or overwhelming manpower, but something far subtler and far more devastating, a revolution carried not in steel, but in the radio waves that knit an entire armored force together. And so history records a simple final verdict, one that resonates from the battlefield of Kasserine to the banks of the Rhine. The Sherman tank was not just a vehicle, it was a network, and that network won the war.